I need to turn the other drive shaft so this one up here lines up.
The mechanics have to precisely line the engine up with mounting points while making sure that no hoses or cables get trapped. 10 minutes later, the engine is in the right position and the mechanics can lower it. Maximilian Schulz and Daniel Kloka now position the engine so that it sits exactly in the center of the chassis. To do this, they suspend a plumb line from the center of the engine and measure the distance on the left and right to the frame. 1 centimeter difference.
That's good.
If the engine wasn't located just right, the mobile crane's center of gravity wouldn't be exactly in the middle, and it wouldn't be possible to connect the universal joint of the drive shaft either. The drive shaft powers 4 of the 9 axles via transfer cases, but attaching it to the gearbox turns out to be difficult.
I'll go down and turn the drive shaft.
Okay.
The holes in the drive shaft don't match up.
Once the electronic control cables have been installed, the marriage between carrier and superstructure is complete. The 16-ton power pack must now be removed from the rotating platform again to make more space for completing assembly of the mobile crane. The enormous telescopic boom of the LTM 1750 mobile crane is on its way to the assembly facility. But before it can be mounted on the crane, Alexander Corona and Patrick Elmer first have to install the luffing cylinders on the rotating platform. Each cylinder weighs 2.5 tons.
We use these templates to make sure that the holes in the rotating platform and carrier match up.
Mounting the wheels of the mobile telescopic crane is not a job that can be done by hand, because each of the 18 wheels weighs 300 kilograms. But that's no problem for this special tire forklift. It enables mechanic Maximilian Schulz to fit the tires on the wheel hubs with ease. The enormous tires have a diameter of 1.5 meters and are mounted on 25-inch rims. They have a thread depth of 2.8 centimeters and are pumped up to a pressure of around 8 bar. Each wheel costs around 2,500 euros, so a complete set of all 9 axles adds up to roughly 45,000 euros.
The eddy current brake generates a magnetic field that acts on the drivetrain while causing minimal wear. This is the preferred system as it increases the life of the disc brakes.
Once the drive shafts are fitted, the workers must turn the carrier the right way up again. To do this, the mechanics have attached a motor suspended from a crane hook to the rear of the carrier. The second device required for turning the carrier over is this giant wheel. In order to install the first component, the assembly workers have to turn the massive structure upside down. The rotating platform is part of the crane superstructure, which supports the telescopic boom at the front and the power pack and counterweights at the back. The hoist cable will later run over these sheaves. The industrial mechanics fit the head and neck sheaves made from a special plastic. The more sheaves, the less power the crane needs to raise a load. It's the same principle used by the overhead cranes at the factory. At the base of the telescoping section, the industrial mechanics now have to install a locking mechanism. First, so that it shrinks, a bushing has to be cooled down to minus 196 degrees Celsius in liquid argon, a noble gas. Andreas Gauss places it into a bore. When the bushing warms up to ambient temperature, it expands and sits securely in place. A steel spring is then placed into the bore, followed by the 70-kilo locking pin, which has a mushroom head on the bottom end.